Yeah, Vincent, I think it's like 5 o'clock in the morning for you now. Thank you for getting up so early for us. If there are any questions, feel free to ask them.
I was wondering, how does it compare to traditional square or V-shaped glitches? Because there's a comparison with the 2019 paper I see, but how does it compare with traditional glitching?
Yes, hello everyone. I hope you can hear me.
Yes. Yes.
Okay, wonderful. Wow, this is amazing. So greetings from the US West Coast. So the table that we put in the paper only references the arbitrary waveform glitches, which they presented. But in their paper from 2019, they also used traditional pulse-shaped glitches and V-shaped glitches. So they used a transistor-based glitch and a kind of simple pulse glitch. And in their paper, they already could show that the arbitrary waveform glitch performs better than those, let's say, more traditional ways of doing the glitch, which is why we did not include them in the table. But if you look up their paper, Shaping the Glitch, highly recommended, you will find those numbers. And we did the same test, so you can add those table entries basically to our table, and then you will have the full picture.
Okay. Any more questions? I have actually one. I know it's written somewhere, it's not part of this talk, but can you maybe tease a bit how to find optimal waveforms?
Yeah, there are clearly one or two things that we noticed in our experiments. So number one is, I think for the different families of microcontrollers or different manufacturers, we noticed that typically there is, let's say, one specific waveform that works extremely well. For instance, for the STM32, we noticed that any attempt that we did resulted in a W-shaped waveform. So we did all sorts of parameters and did a lot of testing, but we always converged towards this W-shaped waveform, no matter which approach we followed. For the Renesas chip, we got slightly more variation, and the shape of the waveform was also noticeably different. So in part, this relates to the search algorithm, so how to make it faster, how to promote features that we like, but it also very much depends on the microcontroller family. And in a follow-up paper, we will explain a little bit more how to select features, how to find them, and how to make the search converge more quickly. And the modular splines align rather well for that. I prepared a small video that shows how the active search is being done, but I think right now I can't screen share. So yeah, there will be hopefully some other opportunity where I can show this.
All right. Okay, thank you. Are there further questions? Okay, then let's thank Vincent again.
Yeah, thank you so much for having me. Have a good day, everyone.